Today we will see water balance. In hydrology, water balance equation describes the flow of water in and out of a system. It is just like an energy balance because how much water comes, that much water goes. So it is the water balance. A system can be one of several hydrological systems such as column of soil or a whole drainage basin. The water balance equation can be used for many basic analysis of water availability in the area. For example, how much water is available for various purposes from the system. The water balance equation for a basin states that all the water that enter in a system in specified period of time must be consumed, stored or go out as surface or subsurface flow. So that can be mentioned in the form of equation as follows: inflow equal to outflow plus change in storage, that is I is equal to O plus delta S, where I is the inflow in system, O is the outflow in system, and delta is the change in storage in a given time period. The inflow into the system includes precipitation, surface inflow, subsurface inflow, whereas the outflow from the system includes surface outflow, subsurface outflow, evaporation, transpiration, and evapotranspiration. So precipitation we have seen in the details, that is water coming on the ground or in the system. Surface inflow, water coming from in the surface to the particular point where we are calculating the water balance. And subsurface inflow, that is below the ground, the water coming to the point where we are calculating the water balance. And outflow, surface outflow, that is water flowing from that surface to other surface. Subsurface outflow, that is from below the ground, the water flows out from that place. Evaporation, from that surface where we are calculating water balance, whatever evaporation takes place, the water forms into the vapors. Then whatever vegetation is there, transpiration from that vegetation occurs, and the combinedly from plants and land, evapotranspiration occurs. The change in the storage includes change in soil moisture storage, change in groundwater storage, snow cover, surface storage, depression storage, channel storage. So, and on that place, the soil moisture changes due to the incoming and outgoing of water. Then changes in the groundwater storage occurs. If snow is there, then snow cover is there. Then at the surface some storage is there, or some depressions are there at that place. So storage in the depressions is there, or in the channels the storage is there. So changes in this storage, that are changes in the storage called, and whatever the total comes, it is the water balance. Now we will see evaporation. Evaporation is the process whereby liquid water is converted to water vapor by the transfer of water molecules to the atmosphere. So due to the mainly evaporation takes place due to the sunrise, sunlights, sun rays. So the evaporation and transpiration, that is taking place from the leaves of the plants, are small for a runoff event and can be neglected. The bulk of these abstractions take place during the time between runoff events, which is usually long. Hence these are more important during this time interval. Now which are the factors which affect the evaporation? We will see one by one. The factors affecting evaporation are vapor pressure between the water surface and air above, temperature, atmospheric pressure, wind, depth of water in the water body, water quality, size of the water body, radiation and humidity. So vapor pressure difference. The rate of evaporation is proportional to the difference between the saturation vapor pressure at the water temperature EW and the actual vapor pressure in the air EA. So what is the rate of evaporation? That is EL is equal to C into EW minus EL. This is the Dalton's law of evaporation. It states that EL is equal to C into EW minus EA, where EL is the rate of evaporation, it is millimeter per day. C is the constant found out by Dalton. EW and EA are in millimeter of mercury. So EW is the water saturation water vapor pressure at the water temperature, and EA is the actual vapor pressure in the air. Temperature. Other factors remaining the same, the rate of evaporation increases with an increase in the water temperature. Increase in evaporation rate with increasing temperature. Next is atmospheric pressure. A decrease in the barometric pressure as in high altitudes increases evaporation. Winds, that means if pressure reduces, evaporation increases. Wind speed. Wind aids in removing the evaporated water vapor from the zone of evaporation and consequently creates greater scope for evaporation. If more wind is there, more evaporation is there. Water depth or heat storage in water bodies. Deep water bodies have more heat storage than shallow ones. A deep lake may store radiation energy received in summer and released in water, causing less evaporation in summer and more evaporation in winter compared to a shallow lake exposed to a similar situation. So that's why in the morning the river water is warm as compared to the land besides the river. Size of water body. More exposed area leads to more evaporation and vice versa. So if more area is there, water body area is more, then evaporation is more. Water quality. When solute is dissolved in water, the vapor pressure of solution is less than that of pure water. Hence causes reduction in the rate of evaporation. So clean water has more evaporation than the the contaminated or solid dissolved water. Thus, under identical condition, evaporation from seawater is about 2 to 3% less than that from fresh water. Turbidity also affects the rate of evaporation by affecting the heat transfer within the depth of water body. Measurement and estimation of evaporation. The amount of water evaporated from a water surface is estimated by the following methods. Empirical evaporation equation, water budget method, energy budget method, mass transfer method, actual observations and pan observations. So here in this lecture we have seen what is evaporation.